Hello, students. So today we're going to be covering our last item in Unit 1. We're going to talk about writing equations of lines parallel and perpendicular to other lines. It's hard to believe we're already nearing the end of Unit 1. So tomorrow and Monday, Friday and Monday, we're going to be reviewing for that test, and the test is on Tuesday. Now, some important reminders for those of you at home. The test is only going to be open for 24 hours. So you will have from 8 a.m. on Tuesday morning until 8 a.m. Wednesday morning to take the test. This is your only window for it because that's what's required of me. So just keep that in mind. Okay, and another thing that I want to say, that normally I don't talk about these sorts of things, but if you're affected by the things that are happening in the news right now, I just want to remind you all to take very good care of yourself, because when things are very stressful and heart-wrenching and just all of these very, very negative things, we have to take care of ourselves, because we can't put good out in the world if we're not taking care of ourselves. So make sure you treat yourself with kindness right now and let yourself feel whatever you're feeling, because I know I'm affected by it, and I'm sure a lot of you are affected by it if you've heard the news. Anyway, so on with the lesson. I just wanted to let you guys know that, I care about you all and I want you all to do well. So on with the lesson. For point slope formula, this formula is awesome at helping us write equations of lines. So if we are writing equations of lines that are specifically parallel and perpendicular, that slope aspect of the formula is going to be pretty important, and we're going to have to identify what the slope would be, which is why we covered that yesterday. So when writing an equation of a line parallel or perpendicular to another line, we must have at least one point on the line, and the slope of the other line. Oh, wow, that was a lot more than I was expecting to write. So when we're writing the equation of a line parallel or perpendicular to another line, we need those two things. We need a point and we need a slope. We cannot write that equation if we don't know those two things, because in order to determine a line that's parallel or perpendicular, we need that slope, because parallel have the same slope and perpendicular have the opposite reciprocal. So at least one point on the line would be our x1, y1, and the slope would be our m. And we write the equation using point slope formula, which is y minus y1 equals m times x minus x1. Which leads us to point slope formula. Sorry, I'm feeling a little bit extra today. So this guy is going to be our champion of today. This is our set of instructions telling us how we can use that point and that slope to write an equation. So obviously, if we're writing an equation of a line that's parallel, we are going to use the same M. And if perpendicular, we're going to use the opposite reciprocal. Which would technically be written like this, but that may get a little bit confusing, but we're using that opposite sign reciprocal. It's not always going to be a negative because it's already negative, it'll become a positive. But that's the idea of an opposite reciprocal. All right, so let's take a look at some examples. So first, let's practice using point slope just to make sure we've got a good idea of it. So if we are given a point and a slope, point and a slope, then that tells us, hey, we can use point slope. Very simple. So right now, we're not going to worry about parallel perpendicular. We're just going to practice using point slope formula. So I know that's going to be y minus y1 equals m times x minus x1. The y and the x are just meant to be y's and x's because that's part of the structure of an equation of a line. The y1 and the x1 and y1 are from the point that they give you. So the little subscripts tell you you're going to be plugging these guys in. So into my formula, I'm going to have, let's use blue, if you like blue. Y minus y1 equals m x minus x1. Now this is all fine and dandy, but I prefer slope-intercept form because this is a little bit weird. We like y equals when we're talking about equations of lines. So we have to do a little bit of simplification. So the first thing I'm going to do is distribute. Because I could add that 1, but first let me get the distribution down. So I still have y minus 1 on this side, but on the other side, I now have 2x minus 8. Now I can go ahead and add that 1 over. Leaving me with y equals 2x minus 7. So this is where you're either adding or subtracting on both sides the number with the y. So that's the basic idea. Every time you write something in point slope, if you want it to be in y equals mx plus b, you're going to distribute, and then you're going to add or subtract that number. Now, what if you're given 2 points? Well, for point slope form, we need a point and a slope. So this is a little bit of a problem for us. However, yesterday we learned how to find slope between 2 points with this formula. So we can take those 2 points and use the slope formula to get a slope between them. So as long as I have either a point and a slope or 2 points, I can write an equation using point-slope formula. Now it becomes a little bit different when we're specifically finding equations of lines parallel and perpendicular, but I'll get to that example in a moment. So if we have these 2 points, we need to find the slope between them. And let's remember that that is y2 minus y1 over x2 minus x1. I'm going to go ahead and do that formula, y2 minus y1 over x2 minus x1. Now I have -8 over a 1 plus 3 positive 4. This simplifies down to -2. So there's my slope I'm going to use. That'll be my m. Now I can plug into point slope. And I'm running low on space on this page. That's no bueno. That's okay. So I'm going to go y minus y1. My problem is I have 2 points. I have a y1, y2. You can use either point. It really doesn't matter. You can pick one that you feel is easier. You can just pick one. I'm going to go ahead and do the one that I called my y1s. So y minus 7 equals my slope of -2 times x minus -3. So this becomes y minus 7 equals -2 times x plus 3. So that double negative becomes a positive. And then we distribute, which I don't know why I put the arrow that way. I'll distribute this way. -2x minus 6. And then I'm going to add 7 to both sides. To get y equals -2x plus 1. All right, so silly little me took the whole page up just to do those examples. I should have figured a way to do it in less space. So I'm going to do something a little unconventional and go on the back of the page. I have not done this before because the markers bleed over pretty bad. So let me take a picture of this real quick and then we can go on ahead. So I want to get that picture in before they start bleeding all over the place. All right, works. Let's go to the back. Oh, it feels so wrong. It feels so wrong. That's my fault for not fitting it all on the page right. Okay, so let's do an example where we find the line parallel. So we're going to find the line parallel to y equals -3/4 x plus 2 that passes through -8, -1, boom. So we have a point and an equation, but that equation tells me my slope. Yesterday we talked about identifying the slope in the equation. Well, it's right there. So I know my point and my slope. So I can use point slope formula, just like we did on the front side. So I'm going to go and do y minus the y coordinate equals my slope of negative 3/4 x minus my x coordinate. Oh boy, there's a lot of negatives there. Let's clean that up a bit. Y plus 1 equals negative 3/4 x plus 8. That's looking a little bit better, huh? Now I'm going to go ahead and distribute. The first part will just stay the same because it's always just x. And now I need to do negative 3 divided by 4 times 8. Well, my little trick is I see what's 8 divided by 4? Well, that's 2. And what's 2 times negative 3? That's negative 6. So this will be negative 3/4 x minus 6. And of course, that's something you can do in your calculator as well, as long as you're careful about it. So I would do negative 3 divided by 4 in parentheses times 8. That way you're keeping that fraction all together, and you should get negative 6. All right, so my last step, I have to subtract 1 from both sides to get y by itself. Y equals negative 3/4 x minus 7. So parallel lines continue to be very kind to us. We don't have to fret too much about them because we just use the exact same slope. We don't have to fuss with it at all. So what if we're dealing with a perpendicular line? Trying to make sure I don't give an example from the work today. Okay, I was about to use an example from our work today. Probably not the best idea. Ooh, what if we do this one's a good one, I think. Sorry for the pause. Okay, so let's find the equation of a line perpendicular to y equals 1/4 x minus 5 that passes through the point 2, negative 5. Let me make sure that's on camera. It is not. Okay. Boom, there we go. So again, we have a point and we technically have a slope from our equation. However, the important thing to remember here is we're finding the equation of a line perpendicular. That means we're not going to use the same slope. We're going to use the opposite reciprocal. So if the original slope is 1/4, we need to use negative 4/1, which is the same as negative 4. And that will be our slope for this equation. You cannot forget that step. You cannot forget it. if you're writing the equation of a line perpendicular, you need the opposite reciprocal slope. So please do not forget this step. This is so important. So let's wrap it up and find the equation of the line with point slope. Y minus our y coordinate of -5 equals our slope times x minus our x coordinate. Remember, formulas are just like sets of instructions, but in symbol form. All right, so I'm going to simplify this double negative here so it doesn't confuse me. And now I can do the distribution. And lastly, I can subtract 5 from both sides to get y equals -4x plus 3. All right, so important notes for today. Let me double check. When you're finding the equation of a line given a point and a slope, you can just plug that right into point slope formula. There's no kind of tricks to it. You plug your slope in and you use your point like so. If you're given 2 points, you have to find the slope between the 2 points. So use that slope formula. Then once you find the slope, you can plug it into point slope with your point and solve down. And lastly, when you are finding equations of lines parallel and perpendicular, you have to remember that rule that parallel lines have the same slope. So your final equation should have the same slope. Perpendicular lines are opposite reciprocals. So your final one should not have the same slope. It should have the opposite reciprocal slope. This is probably the most forgotten step by students. So please remember to find the opposite reciprocal if it's perpendicular. This word is so important. All right, that's all I have for today. So make sure that you check out the assignment and get that done. It's just 10 questions, just like the examples that we did in the notes. It might be helpful to use a calculator because there are some kind of tricky fractions on there that sometimes occur, but it's nothing you can't handle, especially with Desmos calculator. All right, see you later, guys.